Alright, welcome back. So this is lecture 5, and this week we're going to be talking about propositional logic and proofs. And before we can talk about propositional logic, we need to talk about propositions. So I've written a definition here for what a proposition is. A proposition is a declarative statement that has a truth value. And the important point here is declarative. It's a statement which is making some claim, some declaration. And that declaration could be true or it could be false. But a proposition has got to be a declarative statement. So here's an example of things that are propositions. My name is Nick. It's a declaration, it has a truth value. 1 plus 1 equals 5. That's a declarative statement. I am stating that 1 plus 1 is equal to 5. It has a truth value which is false, but it's still a proposition. This is CSE 215. It's a declaration. It happens to be true. Okay, things that are not propositions. Who are you? That's not a declaration. Goodbye. That's not a declaration. X plus 5. That is not a declaration. These are not things that are making statements, right? These are other kinds of sentences in English. So we always want to come back to this definition and make sure that when we're doing something with propositional logic and we intend to be writing propositions, what we're actually writing is a declarative statement that has a truth value. All right, so propositional variable. This is just like a variable in a programming language. It's typically a letter that represents a proposition. So I might say P is the proposition 1 plus 1 equals 5. And when you begin working with these things, I would actually write out something like let P be the proposition 1 plus 1 equals 5. That's completely clear, unambiguous. When I say P, I mean this declarative statement that has a truth value. Here's what you do not want to do. Don't write this. That is completely confusing because we're saying that P is equal to 1 plus 1, which is 2, but that's also equal to 5. So is P 1 plus 1, which is 2, or is P equal to 5, or is P a proposition saying that 1 plus 1 equals 5? Totally ambiguous. So don't write that. When you're writing down what a proposition is, spell it out. Let P be the proposition and then state what the proposition is. It sounds like a picky little thing, but I guarantee it's going to keep you out of so much trouble if you begin all of this work with a nice clean notion of what a proposition is, and if it's very clear to the reader of your work what the proposition is. Okay, so propositions, declarative statements that have truth values, we usually use T and F to represent the two possible truth values, true and false. And this propositional calculus is very old. This actually goes back to work done by Aristotle, 300 BC. So this is, over 2,000 years old, this notion of propositions and doing calculations with them. Now, one thing we can do with propositions is we can use them to create new propositions. We can build new propositions from existing propositions. And this is work that was done, among others, by George Boole back in the mid-1800s. So very old history, right? Early genesis of Boolean logic, for example, and Boolean algebra. So for all of this, we're going to say let P and Q be propositions. And I'm not going to specify what these propositions say. They're just propositional variables. So P is some proposition, Q is some proposition. What we're going to do is create new propositions from old ones. And the first one we're going to use is this funny symbol, which we call negation, followed by a proposition or a propositional variable. This is the negation of P. And we sometimes write this as not P. So for example, P might be the proposition I am Nick, and Q might be the proposition 1 plus 1 equals 5. So if this is the proposition P, I am Nick, then not P is the proposition not I am Nick, which in English we would probably say I am not Nick. But the meaning would literally be the opposite value of whatever the truth value of this proposition is. So if I'm Nick, then not P turns out to be false. If I am not Nick, then not P would turn out to be true, because not P says I am not Nick. So that's a negation. And if we want to understand more succinctly what this operator does, we can describe this by writing what's called a truth table. So we can list a propositional variable P, and then we can list a column showing what not P is. And since P is a declarative statement that has a truth value, and there's only two possible truth values, P is either false or true. And it turns out if P is false, not P is true, and if P is true, not P is false. And this little table right here, this truth table, completely specifies what this negation operation is all about. So truth tables are really powerful. Let me show you a second way that we can combine propositions. This is called conjunction. And in English we think of this as an AND operator. And so P conjunction Q means P and Q. And what we really mean here is that P and Q are both true. So P and Q in this case is the proposition I am Nick and 1 plus 1 equals 5. Is that a proposition? We should question this. I am Nick and 1 plus 1 equals 5. Is that a declarative statement? I would say yes. And does it have a truth value? Yes, it does. The truth value is false, because even though I am Nick, 1 plus 1 is not equal to 5. But nonetheless, P and Q, the conjunction of P and Q, is a proposition. And we can describe what that looks like more formally with another truth table. And in this case, since P and Q each have truth values of either true or false, there's 4 possibilities for the composite of P and Q's truth values. P and Q could both be false, P could be false, Q could be true, P could be true, Q false, or P and Q could both be true. And those are the only 4 possibilities. Whatever propositions P and Q represent, exactly one of these 4 conditions will be true. And we can list what the conjunction of P and Q is in each of these cases, and it turns out to be false in most cases. But if P is Q and if P is true and Q is true, then P and Q is also true, and otherwise it's false. All right, and we can also make what's called a disjunction, which we could think of in English as an OR, and that's written with this V-type symbol, P disjunction Q. And the truth table for that turns out to be true if P is true or Q is true. And if P and Q are both false, then P or Q is false. And there's a different version of this, which is an exclusive OR. And we sometimes write that with this plus sign with a circle around it. And we don't have a fancy sounding term for that, like conjunction or disjunction. It's just an exclusive OR. But an XOR is very much like a disjunction. It's very much like an OR, except you're only allowed to have either P or Q true, but not both. If P and Q are both true, this exclusive OR is false. So here's some truth tables describing these ways that we can create new propositions from old ones. And we're going to use these a lot. They're going to become second nature to us before long. But before we start working with these too heavily, we want to look at one other way that we can combine propositions to create new ones, and that's going to be called making a conditional statement. So that's going to be the topic of our next video.